Hi everybody, thanks for checking out another math video here. This one is going to be about solving non-linear inequalities. Actually, let me strike that. It's actually going to be about solving quadratic inequalities. The phrase non-linear just refers to any kind of a function or expression that is not linear or not a straight line. And so this process will be used by you in future math courses for other kinds of nonlinear functions, but this one we're only going to focus on quadratic functions, something like those there, x squared minus 6x greater than 0. So in a quadratic expression set less than or greater than 0 is what we're talking about here. We are not talking about graphing a parabola and shading inside or outside the parabola. If that's what the task is that you are presented with as a student, then this is not the video for you. But if you are solving quadratic inequalities such as those that I've written right there, this is your video, okay? And this is an interesting process. I'm really glad that you're watching this video. So let's get started. I would like to make a couple of introductory remarks about this topic. Generally, solving an equation means to use some algebra to find a solution, and a solution is usually a specific number, or maybe numbers, to an equation. However, an inequality is different, because when you solve an inequality, you're finding an interval of numbers, such as x is greater than or equal to -2, or 0 less than x less than 3/2. It's an interval of numbers, or a solution interval, we call it. Okay? Parts of this process that you're going to see here are not algebraic. We will use some algebra to find parts of our solution, but you can't finish it with just algebra. It's very interesting in this way. So we will use basic arithmetic, or maybe in another video I'll show you how you can use graphing to solve these kinds of inequalities. And one final, I know this is kind of repeating, but this process will be used for other kinds of inequalities. And in this video, we're only going to focus on quadratic inequalities. Okay, so let's pick one. Like that, x squared minus 6x less than 0. All right, and remember, our goal here is to find all the x values that make this a true statement. That is kind of a hard idea to actually wrap your head around at first until you've done a few of these. But I want to say it here at the beginning. That's what we're looking for. We're looking for all the x values that will make that true. And you may be surprised by what we come up with. All right, so here, our first step in solving a quadratic inequality is to find what we call the critical values, all right? Sometimes we also call these zeros. And basically, the way you find it is to solve it as if it were an equation. All right, and find out what the x values for that are. So we'll solve it as if it was an equation, and here your algebra, hopefully you've had some practice solving quadratic equations already, and you could solve this quickly by factoring, and you get your values x equals 0 and x equals 6. These are not the solutions to our inequality. However, what we call these are the critical values that we are looking for. All right, these numbers actually form the boundaries of the solution intervals that we ultimately will find. Okay, so let's see. The next step there is to take these two critical values and we're going to just place them on a simple number line. All right, at this point we're kind of done with the algebra. There's no more solution process using algebra here. We're going to take those two critical values that we get, put them on a number line, and now what we're going to do is choose a number in between those two values and test it in the original inequality. All right, so now we're using arithmetic. We're going to take a number, and it doesn't matter which number you pick, any number will give you the same kind of result. So let's say we pick 2, and we'll take positive 2, and we'll replace the x in our inequality with positive 2. So, all right, so we had x squared minus 6x greater than 0, so you replace the x with 2, and what you end up with here by working that out is -8 greater than 0. Well, that's not true. -8 is not greater than 0. This is a false statement, which means that that interval from 0 to 6 is not a solution interval to this inequality. So we're not done. We found an interval of numbers that does not work. And actually, with more practice, you'll see that when you find one that does not work, you've actually kind of by default found the solution intervals that do work, but we'll get to that later. So that 0 to 6 interval does not work. So what we're going to do then is try to test numbers outside of that interval, such as -1 or +7. All right, and we're going to replace those numbers into the inequality, replacing x, I mean. So when you work that out, for both of them, we happen to get the same statement, 7 greater than 0. Those are true statements, all right? And that means that we have found the solution intervals. So the interval between 0 and 6 did not work. By default, that actually means that the intervals outside of that region do work. But we tested it here just to kind of verify that. So any number greater than 6 will make that inequality true. And any number less than 0 will make that inequality a true statement. So we have in fact found the solution. Those critical values are the boundaries of those solution intervals. Okay, so now we found the solutions. Let's explore a little bit how you express the solution. Okay, so you may be already familiar with this kind of graphing representation of a solution to an inequality with that open circle and an arrow, or maybe just kind of a solid line or something like that. So since the inequality was just greater than 0, the values 0 and 6 are not part of the solution. All right, so we indicate that with that little open circle there. Every number greater than 6 is part of the solution, and every number less than 0 is part of the solution, but the exact values 0 and 6 are not part of the solution. So that's what that little open circle indicates, and the way to express that using inequality symbols is pretty simple. X less than 0 and x greater than 6. That's inequality notion right there. And so you're welcome to use that. Some teachers prefer, some books prefer using another style of notation. It's called interval notation, and it uses parentheses and squared off brackets to frame the solution intervals. So this is how this solution interval would look using interval notation there, with -infinity, comma 0, with parentheses, union, that's what that U symbol in the middle is, the interval 6 to positive infinity. So that's the interval notation style of expressing those solution intervals, and you are welcome to use that if you're familiar with it and you like it, or the inequality notation, okay? Let's try another one. So here's another inequality, a quadratic inequality, x squared minus 3x minus 10 less than or equal to 0. Okay, so let's go ahead and solve it as if it was an equation. And quickly, this also factors nicely. So we get x equals 5 and x equals -2. Put those two numbers on a simple number line. And now we'll test a number in between. This is nice because we can use 0. 0 is a really easy number to test in an equation. And very quickly, we get to the statement -10 is less than or equal to 0. That is true, of course. So that means that right off the bat there, we found the solution interval to this inequality. It's between -2 and +5. And the graphing representation of that would use this filled in circle because it's a less than or equal to inequality symbol there. It means that the -2 and the 5 are actually part of the solution. The inequality symbol expression of that solution interval looks like that there, -2 less than or equal to x less than or equal to 5. You would write that as a single statement with two inequality symbols. Okay, instead of the other one was two separate intervals, and so you have to express them as two separate statements. Absolutely have to express them that way. You cannot express the previous example with a single inequality statement like you see before you right now. All right, the interval notation style would look like that, with a squared off bracket representing the inclusive values of -2 and +5. Okay. So that's about enough for one video here. I'm going to post another video that has another solution, another couple of examples, maybe even 3 examples, which will include examples where you can use the idea of graphing to help you find the solutions to these quadratic inequalities. Okay, once again, thank you very much for watching. Hope you're doing well, and stay tuned, and let's do some good math. Thank you. Bye-bye.